Today, guys, we are going to study the topic subtract expressions. Okay, I'm going to write it. Subtract expressions. On the top of the page, you can see it. And now, in the example 1, we are going to subtract expressions by using properties. We are going to do the same, guys. Like, remember when we were studying about addition? We are going to do the same, only that instead of an addition, we are going to subtract the expressions that we obtain in here. Lita's family wants to put a tile border around their swimming pool. What expression represents the total area of the border? Okay, they want to find the area only of the border of the pool, and you can see that we include everything, okay? At the beginning, we include the part that contains the border and contains inside of the part inside of the pool, okay? But later, we are going to subtract the area that is only for the pool, okay? To obtain only the borders, because we want to obtain only the area for the borders of the pool. Okay, so you can see that each border has a measure of 2 feet. Each border is 2 feet, including the length and the width. So we can write an expression for the area of the pool only. Then we write an expression for the area of the pool plus the tile border. And later we are going to subtract, okay? So the length of the tile border is 2 plus, this is for one border, 2 plus 2x plus 14, you can see that is inside the pool, okay? They write you on the drawing that you have, 2x plus 14. This is the measure that they give you for the pool. Plus 2, again, that 2 is the other border. This is the other border, okay? So we have that this is 2 plus 2 plus 14, you have 18. So 2x plus 18. But in this part, you are including everything. You are including the length of the tile border, and you are including the borders, and you are including the part with the only the water of the pool. Okay. So we have the width of outer edge of walkway, the border that is in the bottom. Okay. We have 18 because we add the borders and we add the part inside. So 2 plus 14 plus 2 again is 18. We can obtain two different expressions. The first one is when we only have the area of the pool, width multiplied by length, 14 multiplied by 2x plus 14 square feet, okay? What is this, guys? And why are we multiplying in here? Because remember, the area when we try to obtain for one rectangle is to multiply the height by the length. In this case, the width. They are using the width, okay, by the length. So the width multiplied by the length. And for the other part, we have the area of the pool and the tile border. So we are going to subtract these two quantities. 18 times 2x plus 18 square feet, okay? And what we can do now, we are going to subtract the total of the pool with the borders minus the expression that we have only for the pool. So we use properties. We move now to the right part of the page. We use properties of operations to subtract the expressions. Area of pool plus tiles is 18 multiplied by 2x plus 18 minus 14 multiplied by 2x plus 14, okay? This is what we have until here. So now what we need to do is to start multiplying. Remember, The distributive property states that you need to multiply all the terms inside the parentheses by the term that is outside. So 18 times 2 is going to be 36x plus 18 times 18, that is going to be 324. You have it on the book, so I only copy this because we already solved the multiplication, okay? So 14 times 2 is going to be 28x minus 196. Minus 196. That 196 is the multiplication of 14 times 14. Now we can use the commutative property. We use the distributive. When we distribute the number, when we multiply by all the terms inside, is the distributive property. Now we can use the commutative property to reorder, okay? Reorder the terms that we have for the operations, okay? Then we continue with this. 36x minus 28x plus 324 minus 196, okay? 36x minus 28x is going to be 8x plus 324 minus 196, that is going to be 128, okay? This is what we have for this. So the area of the tile border is 8x plus 128 feet to the square feet. Okay, this is the measure for this. So do you understand what is the idea of this? They want to know the measure only for the borders of the pool, but you cannot find the area only for this. So we find the area for everything, including the borders and including the water. And later we subtract the part that includes the water, so we can only have, okay, the borders. We don't include everything. Now we can have the area and we can know the measure for this, okay, in the borders. So, okay, in the example 1, we have about this using properties. In the second example, we need to subtract expressions with rational coefficients. So in the example 2, we need to subtract expressions with rational coefficients. Okay, so I'm going to move just a little. Then, okay, we can start this. I'm going to continue with the second example. Subtract expressions with rational coefficients. This example is a little long, so we are going to take more time in this. Yada is comparing membership cost for 2 gyms. What is the difference in membership cost after M months if she joins Be Strong instead of CP Health Club? So we have the prices for 2 gyms, and she wants to know what is going to be the difference in membership cost. M is representing the number of months because I don't know the number of months, okay? So you have the information at the right part. For CP Health Club, the cost for to joining is $49.95. And for each month, she is going to pay $19.95. In the other gym, Be Strong, is going to cost $10 off the first month, so she's going to obtain $10 less, and $24.99 for each month. So we need to write an expression for each membership cost for M months and subtract. Remember that we are subtracting, so we have the gym Be Strong minus the CP's Health Club. I'm going to write everything in here. So for the first gym, Be Strong, we have $24.99 each month minus $10 off. Remember that she is going to obtain one discount. So she has $10 off. Minus, because I'm subtracting, remember, for the other gym, that is CP's Health Club, $19 with 95 cents plus $49 with 95 cents. This is the cost that we have for each gym. Okay, the information, you have it at the right part of the book for the first gym and the second one, and we subtract. Okay, we solve this subtracting. Then what we have in the other part, 24.99 minus 10 plus, and what happens when you have this negative in here? This negative is going to affect this number, and it's going to affect this number, right? It's going to affect everything inside the parentheses, because it's like you have one imaginary. It's like you have -1 multiplying by all the terms. Yes, because we have one imaginary one in here, an imaginary number 1 in here. So we have 19.95 plus 49.95. Okay, and what is going to happen with the -1 is going to distribute by all the terms inside the parentheses. So we have 24 point, I'm sorry, because in here I didn't write the variable, is m, 24.99 m minus 10 plus -1 multiplied by the first term inside the parentheses, that is 19.95 plus -1 again multiplied by the term inside the parentheses, that is 49.95. Okay, but we forget something important, and is that the 19.95 is including the variable m. Okay, this is related with the variable m. And now what we are going to do, guys, the first thing that we can do at the beginning of the problem, distribute the minus for all the terms inside the parentheses. You have it, -1 multiplied by the first one, and -1 multiplied by the second one. Okay, so we only change the sign now because we cannot have positive and negative. These signs is going, they are going to be positive. So we have 24.99 minus 10 minus 19.99 m minus 49.95. So we already solved the distributive property. Using the distributive property, remember, we distribute the minus by all the terms. Then we use the associative property and the commutative property to move the terms. Remember, we reorder the terms because we need the like terms together. We need to have terms that has the same variable and the terms that doesn't have any variable together. So we have 24.99 minus 19.99 m. I'm going to write the variable in here. Minus 10 minus 49.95. Okay, and in the book they separate using parentheses, so you can separate. These are the terms that has variable, and the terms that doesn't have variable are outside the parentheses. Okay, so 24.99 minus 19.95, sorry, we obtain 5.04 m minus the other terms that we have. This is addition with negative numbers. Remember, they have the same sign, so we are going to add. Okay, and we obtain 59.95. So what does this mean? That Yada will pay $5.04 more each month at Be Strong, but will start with initial savings of $59.95. Okay, so the last one that we have is the example 3. example 3, we subtract more complex expressions. But in here we don't have anything complex. We are going to do the same. Remember, order the variables when they are the same. It's exactly the same that we do when we have the subtraction and the addition, okay? The only difference is the sign. Remember, the operations are different, but the procedure is the same, okay? The idea for these expressions is the same. You order the terms that has the same variable. So if we need to subtract more complex expressions, we have 5j minus 2q plus 2 over 5 minus 4 minus 3j minus 1/2 q. So what we are going to do, guys, we in this case distribute the minus sign or minus 1 to all the terms in the second expression. So I'm going to change the signs. 5j minus 2q plus 2 over 5, and I'm going to distribute the minus. This is what I was telling you at the beginning, that we can distribute the minus since the first moment. We only change the signs. For example, this is positive, so it's going to be negative 4. In here is negative, so it's going to be positive. Remember, negative times negative is going to be positive 3j plus 1/2 q, sorry. Remember, we distribute the minus by all the terms inside the parentheses, okay? And now we only need to solve. In here, we already distribute, so we can take out of the parentheses this, and we can order the terms that has the same variables. So 5j plus 3j, I'm going to take out of the parentheses and I'm going to order, okay? 3j minus 2q plus 1/2 q plus 2 over 5 plus minus 4, sorry. So we only check if we copy well the exercise. 5j plus 3j minus 2q plus 1/2 q plus 2 over 5 minus 4. Okay, so we only solve the operations. 5j plus 3j, we obtain 8j, and in the other one, negative 2q plus 1/2 q, we have 2, and we subtract 1/2, is negative 1 and 1/2, okay, because we only take 1/2 out. So subtract the operations, you obtain an improper fraction, and later they convert the improper fraction into a mixed fraction, okay? You need to remember about this. Remember, in the first partial, the second partial, we used a lot of fractions, okay? So it's only to remember you about this. So we have negative 1 and 1/2, 1 and 1/2 q, 1 and 1/2 q, okay? This is the fraction, 1 and 1/2 q, minus 3 and 3 over 5. And this is the result of this operation when we have 2 over 5 minus 4, okay? So we subtract again the fractions. It's like you have, for example, 2 over 5 minus 4 over 1. Remember that we add one number 1 at the bottom, so we can subtract. You subtract the fractions. If you don't remember exactly how to subtract the fractions, you need to practice more about this topic, okay? Add, subtract fractions, multiply, all the operations, including division too. And important, how to convert it into improper fractions. So this is the result. So the simplified expression is 8j, sorry, minus 1 and 1/2 q minus 3 and 3/5. Okay, this is for the first one. for the example 3 when we have more complex expressions. So I think that I'm going to finish in here, guys.